me. I couldn't stream, and I logged in with the other
Okay, well,
user.
it says live stream enabled. I just got the pop-up.
Yeah.
Oh, and this one's fine. It's Thursday's call. I just enabled this one.
Hmm.
This one I created. I don't know what maybe I did the other Thursday one too. I just did it wrong. I don't know. But the Thursday one is not set up correctly, so I'm probably gonna have to edit it or redo it.
Okay.
Yeah. Just you gotta remember to do that.
That's
I got a bunch of people who were complaining after yesterday's that they couldn't get the video on LinkedIn or something. So I guess people do watch it there based on the complaints.
Yeah. Good. How to know, right? Squeaky
Yeah.
wheel.
I don't worry, I promised them a complete refund. It's like when they complain about my software having bugs in it. You're getting a 100% refund. Every dollar you spend.
Speaking of videos, does that Cultura thing really even work for us? I haven't found it very useful.
We haven't updated it in a while, I don't
Marcos?
think.
I haven't posted yesterday's, but I'll go in and let me do that now.
I think it works. I always find the crazy things I've said and I don't know. I think it's pretty good. It's not always up to date, but
Yeah.
Stop.
Being organized.
Hey guys.
hey. Oh, I see
If
we
you
got
forget
Ocean
someone at
back.
the foundation with an email, just go claim our account at thegoodstack.org. It'll open up a bunch of software discounts and
We
freebies.
use it.
We already do it.
You have it already?
Yeah, we do that.
Okay.
There's a couple others that I think we signed up for as well.
Like TechSoup, yeah, and those, yeah.
Yeah, I got to. If there's another one, let me know.
So I set up my screen pipe tool. So now everything in my laptop and screen and whatever is being recorded and sent into my vector, which is kind of a cool loop.
Oh,
I don't know
sweet.
if you guys have seen screen pipe at all, but it's kind of cool.
Screen pipe? What's the
It's an open source project, but I've got a better version. I'm not sure if they
Records
like
everything. Yeah. I already updated my setup with that. And last week I started
Make
using
sure
screen recorded. Yeah.
make sure you use my obfuscation, otherwise you're
Yeah,
everything's-
your OS pipe is now in between, so I
Yeah.
just added it today. So
exactly.
well,
And
maybe you can go through that today, that'd be cool.
Yeah. Yeah, remember, it records everything, so you might want to
yeah.
choose what you're surfing.
Definitely.
I just bought that new Mac Mini, but I haven't opened it
Oh,
yet.
nice. Get tail scale on there, and the two most important things if you're using the primary or secondary machine.
That would be my secondary.
Yeah, I use tail scale and parsec. So parsec is the best for remote desktop. There's no latency, and tailscale allows me to get access to it wherever I need to, like code spaces or when I'm on the road or something.
Mm-hmm.
Those are the two primary, and then I just install Claude on it and let it do its thing. All right, here we are, top of the hour.
Did you already have discussions about the new Gemini Pro?
Oh yeah, what do they do now?
Did you check what they printed out, like the results from the code test, that it was the 8th in the world? Did you already see that
No,
from yesterday? Okay.
no, I missed that.
I'll pick those links up. Sundar Pichai did announce that in Twitter yesterday. Pretty solid results. Codeforce's 3,455 points.
Okay, cool. I'm gonna hit record here in a sec. So and this is this is already broadcasting to, I think, YouTube and LinkedIn. So this one seems to broadcast. All right. Recording. Here we go. It's Friday the 13th. Oh, I should have checked the calendar before we started today. It's a lucky. That's lucky, right? Isn't 13 a prime number? There you go. I love 7, 11, 13, anything prime. And I think it's prime. I can't think what's it divisible by, but never mind that. How's it going, Rob?
Great, 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 great. How about you?
Guys.
I'm good. Yeah, it's good. Good. Yesterday, it's been a weird week of, we started at the Toronto sort of meetup, and I guess I rambled for 2 hours, and everyone said I went full crazy on the second hour, and so there you go. I guess I was in the right zone for crazy discussions this week. Yesterday's was kind of out there too. I don't know. I just ramble after a while, but yeah, it's
There's
fun. Lots of stuff being created.
there's so much taking place. We don't have any dedicated um, uh, lightning talks today, so there's tons of room to cover some of these topics. Kenna did have his inaugural meetup yesterday down in Halifax. So they had a
Nice.
great event. So a big shout out and congrats to all the folks down there in Halifax. And then what's
Sorry.
go ahead, Alexi. How are you?
I'm good, good. I'm just interested. So there was I'm kind of trying to see more about the AI space. So there was a new AI video model, which was Dream 2.0, released by ByteDance, which is the creator of TikTok in China. And the really nice thing about Dream 2.0 is that it's really good with physics, actually. And a lot of people are really impressed about it so far. So I was wondering if you have any additional comments to take upon this topic.
No, haven't tried it. Sounds like it's just a video model, or it's like a world
Yeah,
model? What?
it's just a video model. I believe it's in early access, but you can find basically videos that people have posted online on Twitter, on X, about the Sea Dream, and a lot of people are really impressed. So there was an episode from Seinfeld actually, which was recreated, and it looked very similar. So a lot of people are just being amazed by the model so far. So interestingly as well, you can people usually test the model using uh, Will Smith eating spaghetti, and you can see in just about 2 or 3 years just how far AI has come for video models. But I mean, I don't know if that really aligns with what we're doing in AI, or maybe there's some way in order to integrate it. Maybe making an agentic system that makes video models or something. I don't know.
It's certainly a pipeline to explore, eh? There's
It's
the big things like there's so much that's happening right now. The things that I'm hearing about in conversations and just out over the landscape. I mean, it's really clear that en masse, a huge swath of people have clicked in to the power of a singular agent with some autonomy and the ability to conduct actions and do tasks. And I mean, again, you had Agent Browser Roof, I think about a year ago, and certainly we've all been using and deploying swarms. But the level of awareness that's happened now is still not even to the degree of fully formed teams, let alone swarms. And everything that we've been seeing over the last few months, but specifically what you were covering yesterday, Roof, and a lot of the input of of very well placed and experienced professionals and professors in the space.
yeah.
Is that the nature of research and development is changing, and how the frontier gets explored, and all of these tools converge on exploring new science, new combinations, and new papers rapidly. And I think that's one of the things that that you've been a beacon on, is in terms of how to utilize swarms and agents and the ability to write code on the fly and pair that with scientific exploration. So the whole nature of research and development is evolving. And when we talk to executives, I'm still encountering C-level executives that haven't thoroughly used even the concept of deep research, let alone well-defined recursive pipelines of research agents. So I mean, this is a big field. And
It's funny. Someone sent me a note saying that, we're celebrating the 1 year anniversary of vibe coding. Like, all right, so I'll bite. What was I doing? What was I doing 3 years ago?
right.
Right? It's like somehow some random blowhard came up with the term a year ago, and it wasn't a thing before before that was termed. But before that, us collectively, we were creating all kinds of things in a, I guess what we were considering prompt engineering, I guess, or a prompt programming.
Yep.
If you want to go with my subreddit, it's certainly not necessarily a new thing, unless 3 years now counts as new. 3.5 years, I think. But
We
yeah,
should search.
apparently. Oh, sorry. Go ahead, Brad.
Oh, I was just I remember we did a search earlier about the term agentics when you first used that. I forget the exact date, but it was like 2 years ago. So just the term agentics was new, and it was done on this actual show with Rue
Yeah.
saying it kind of thing. So it's pretty cool.
Yeah, it's funny that a lot of the trends that we're seeing like right now, like that a document that the folks at Anthropic came out with, apparently trends for 2026. I guess we're maybe the earliest of early adopters, but those are things we've been doing for quite a while. Like most of them are at least 18 to 24 months old. It's just
That's right.
I guess.
Yep, spec-driven development, right? That's only really been on the surface or on the radar of enterprise for maybe 3 to 4 months. It was when they flew me out to Belgium to
Mhm.
speak at Devox with the IT teams of the blue chip financial institutions in Europe. That first slide that talked about your work and the Genix Foundation and this community over the last 2.5 years, talking about the escalation from chain prompting to prompt chaining to swarm orchestration and development. Entire other talks spent the whole hour on that first slide. So, and that was 4 months ago. And the world's still just catching up to the idea of autonomous singular agents. So, yeah, that lag between the frontier and adoption persists even now.
So the question, and we were mentioning this before we started the show here. Early this morning, I still have room for the random calls that people book on my site. Not a lot these days, but some people do find their way in there. And this guy was a previous sort of adjudicator for the U.S. Patent Office. And he's a lawyer, and he left, and he's starting some kind of patent AI company or something. But what was interesting is, I'm hoping not over speaking, and if you're on, feel free to say something. What he was telling me is like our prior art is like epic, and he says, looking through some of the repos that we've put together, that we've comfortably thousands and thousands of potential patents that we can file. To which I said, well, how much is that going to cost, right? How do you
Right.
file, 10,000 patents? If every patent costs you X, and that's going to be millions of dollars. And he said that there's a little known sort of loophole. I don't know if he didn't say loophole. I say the loophole, but a little known sort of tactic that allows you to bundle related patents. So we've got a year from, even if you've published them or like the code publicly and people are using it, to basically get the patent. And what he was suggesting is, even if you're benevolent about these patents, you want to give them away or protect the industry against evildoers, you should just take them, do a 10,000 patent application, and basically sort of corner that part of the market. Now, I'm not against it. It certainly seems like an interesting tactic, and it does a couple things. One, it protects everyone in the community from the bad actors that might want to use those against us. But it also acts as a kind of proof of the prior art beyond just me and my repo or our collective work. Something to consider.
Ruth, are you familiar with Accelerando? It's book from like, I don't know, 2014 or something like that.
No, what is it?
So I heard about it from Moonshots, which is like Peter Diamandis. It's
Great
Yeah.
podcast.
an
Yeah.
amazing podcast if you heard it. And this guy AWG, he is like he spends all his time talking about AI and the rest of it, or whatever. But there's a character called Manfred Mantz, and he's basically a venture altruist. So he just races ahead and releases concepts strategically, files lots of property patent applications, and then I it just reminds me of you. So you might
Well, maybe
enjoy that. Looks for the
so.
Monmouth.
Yeah, I know we should probably talk to John and others on what their opinions are on that. But again, as long as we're somehow altruistic in regards to those, I don't think we want to carry it like a big stick. But
Mhm.
if we can carry it to empower everyone that adopts similar methodologies and technologies to do that without worry of a giant corporation coming and suing you to death, then that seems like a good reason to do it.
Yep. So we'll table
Oh, yeah.
that for Alex, John Messing, and Alex DeBold to to begin to rally the troops around. John, we were just saying that the committee has been discussing various aspects, and I'm sure you'd be welcome to more legal minds if there's additional interest and talent in the community. This is a big topic that could be explored pretty thoroughly.
Yeah, for sure. We've got some open space today for anyone that wants to present. I see we've got I think I saw Ocean on there. How's it going, Ocean?
Not
I think I
bad. How
saw
are
it.
you?
Good. How's New York treating you?
New York has been cold, very cold. Well, it's getting slightly better today.
Yeah, but it's a winter cold. It's not so bad. I'm in Toronto, so it's probably not as bad as here.
Yeah, it was like minus 20 degrees Celsius a couple of days ago.
Oh, jeez, yikes. What have you been building?
Oh, today I'm building a Rust, basically a translator from LLBC to Lean. So during a formal proof, how you get let's say, a Rust code to be machine checked is you extract the Rust into LLBC, and then you give LLBC into Lean, and then you plug that Lean back into your proof, and then it still builds. So that's how you say, oh, the code is now machine proofed. And then the tooling for that right now for the formal proof Ling and then Rust is pretty awful. So I'm just building one myself.
Yeah, you're right up my alley. I did I don't know if it's similar or not, but it sounds similar. You should check out my Lean Agentic. It's also Rust, obviously. And what I was trying to do, I took the Lean 4 approach. So basically what I did is I did a super fast version of Lean 4 that I could then use for basic mathematical proofs. So what that really is doing is creating novel mathematics in really low latency. So it's like, what's the most novel form of math that will solve my problem to do whatever it is I'm trying to do? And then how can I do a cryptographic proof of that, both in terms of functional proof as well as a kind of cryptographic stamp of when and how it was achieved. Yeah, I call
So
that Lean Agentic.
I have roughly about 100,000 link for proof now over various kind of things. The center of it is a Rust microkernel. It basically will guarantee security invariants are end-to-end, like unchanged, no matter which code path you go through. That is the whole thesis. And then on top of that, I'm building my kind of like a second chapter of my thing. Not moving away from Lion, I'm calling the second chapter Kive. Basically, it's a bunch of application layers that build on top of the Lion microkernel that brings additional guarantees. For example, like I have a system called scoring system for rag retrieval. And then one of the guarantee I'll add is it will produce the same kind of scoring no matter which platform. And then all of those can be proven in math. And then it would be interesting to get out of Ling 4 into something else. I'll check your stuff out.
Yeah, well, it's one of the agentics.org projects, so feel free to contribute if you want. It's all Rust. I think there's some from TypeScript in there as well. I'm sure it's been a while since I've looked at. Yeah,
I'll open source the new tooling I'm doing. That thing will definitely help out a lot because a major thing is Ling is not able to model a lot of Rust stuff. And then in order to make those Rust and Ling work very well, you have to do a lot of hacking. And then that ended up not being production codes. So I want to like get the production codes directly into proof instead of having to do actual hacking.
Cool. Well, it sounds like a great project. Let me know how it goes. Definitely something I've been excited by. So this week, speaking of proof, this week has been an interesting week in terms of, discovering kind of crazy things. And for those who weren't on the call yesterday, I've gone down yet another rabbit hole. So maybe I'll take a minute to describe some of the rabbit holes. Hopefully I don't crash my computer. I shut some things down this time. It crashed yesterday, right when I was about to present. So
Roof,
fingers crossed.
Roof, I just wanna. Have you ever thought about actually using a different language for agentic applications? Because in a recent survey I actually saw, or actual study, it says that the Elixir programming language actually performs the best for agentic coding. So have you tried that?
The Elixir guy, it's total BS. It was garbage. It's like saying 99% of Python fans think Python's the best, right? It's a self-fulfilling. Structurally it's silly. I don't know. I like Rust. It works with Rue. I've tried Go. It's kind of similar. It's maybe a little better for like CLIs and things. But if I was looking at programming language to truly move the needle for a lot of the types of really complex distributed parallel things I'm looking at, I'm probably looking at Julia, right?
And Julia is interesting, but I have a general question. I asked it a million times. Like, so when people say like Elixir is better, right? How do you actually measure like better or worse? Is there still like a number like you can?
It's completely arbitrary. So
because that's what I'm trying to develop. Like because if you get the system and you throw it in some box and they say, yeah, this system is 15, right? And this system is 25 and bigger is better, right? Then you can say this was developed with Elixir, it gets you 25, Rust gives you 15. But is there a metric like that to say what's better and what's worse? Like I'm still looking for one. So if anybody finds out one, let me know. Because SWE bench is completely like artificial because that's not how like people develop like
I don't know. I looked at it and it was kind of it didn't seem better to me. I don't know, maybe I was because I'm more familiar. Julia programming versus Elixir versus Rust. So Julia is scientific, Elixir is scalable web apps, and Rust is systems programming. Now it says it's systems programming, but I'm building desktop apps in Rust that are 5 MB in size. I can build anything with it. So when I show you guys my desktop tool here, this is all Rust, right? So the guys, well, you can't build desktop apps or you can't build web apps. Well, I can build all that. I can build my WASMs. My latest update here, the OS pipe. I've integrated the screen pipe system, so now this is tracking all the work and all the things that are happening on my desktop in real time. I've got a semantic, and this is all Rust, right? So I can see I don't know, I'll type in Zoom and see what my Zoom calls. I can see what I'm using. Here's my flow state. Here's when I'm distracted. That's kind of cool. It says when I'm not looking or paying attention. Sorry, guys. Wow. Content analysis. Here's all the things I only been running this morning because I built it last night. So this is doing a real-time analysis of the things. So it sees that I'm working within the Root Vector memory tray, which was the app that you're looking at right now. I got Brave Open Zoom, which is I closed a bunch of stuff because it was running too much. Here's my timeline and my captures. This is all being fed into a vector quantum style database just because I'm on a quantum kick. So I can see all the captures that are happening. You know, I
Hey,
can
Joe,
see a knowledge
can,
graph.
Yeah.
can you
Anyway,
please help me? Can you please help me to understand the quantum? How you do the quantum? I'm trying to
yeah,
understand.
that's actually what I want to jump in here in a minute.
Yeah.
Okay, so for those who are interested in piping your direct output of all your screens and audio from your computer, I've obfuscated your personal identifiable information, and hypothetically, if you don't want certain websites or things you're doing to be included, you could do that as well, but don't do things you shouldn't do, I guess. But the real question in terms of the thing this week for me is this kind of intersection of quantum and specifically DNA. So I went down that rabbit hole earlier this week, and you can see some of it here. I got several libraries. I got to probably clean up my crates folder here, but I'll do that next week or something. But anyway, the RuQ system is essentially creating a kind of simulated state of qubits. So qubits is interesting because it's this kind of it's a naturally occurring vector sort of latent space, right? So it works particularly well for this idea of translating this into a sort of so from a kind of roadmap of sorts to sort of a different structure, and so that's why things like DNA work really well. So in the most simple terms, what I'm doing is creating a sort of layered approach to simulate the structure of a quantum computer without ever actually having to use a quantum computer to do that. Now, a few folks have reached out and said that they have quantum computers, Danny and a few others. Let's see what this does on a real quantum computer. But at the most important part to look at when you think about the quantum stuff that I'm doing is again, you guys have heard about my min cut algorithm that I'm so excited by recently. I'm looking at the inverse. I'm trying to separate all that noise that exists within a quantum space, which is like 99% noise, and then try to find the integrity of the system to find the signal, right? And I do that really, really fast. So once I've got the signal, I can basically only focus my attention or the attention model and the tensors and the GNN on those things and get back to those spots extremely quickly. So it kind of acts like an adjacent guide for the quantum system. So so you can see here that I've got noise in the noise modular. I've got a lot of it's just kind of decoherence and noise sort of optimizations. But once I had that in place, I was able to then create different forms of stabilizers, and I was able to start running these kind of really advanced quantum-like, not actually quantum because I'm not using a quantum computer, but quantum-like algorithms that then start behaving really interestingly when applied to different problems. Specifically, it allowed me to organize the quantum or vector space in a quantum-like sort of pattern, which was actually really good for sort of finding my way through large amounts of information really quickly. So then I took it further. I'm like, is this can I prove it? Can it do this sort of thing? And the other thing that's important to know here, and this is something that I've been sort of pushing a lot lately. It's not the amount of code that I'm creating. It's actually the inverse. So all of this rather large library was able to be done in 24,000 lines of code. And my latest thing I'm bragging about is I did that in 24,000 lines of code, not 250,000 or 2 million lines, right? So I think the key here in a lot of what I'm doing, and back to this question of Julia versus Rust versus whatever, you can create these microscopic apps. Like I can take my entire algorithm, all the root vector, I can compile it to a WASM, and the thing is 384 kilobytes, right? And if I tried to do that pretty much in any of these other languages, Python probably being the worst, it would be probably hundreds of megabytes, if not gigabytes in size. And that's a key sort of differentiation. Now, when you look at things like Julia, which is again sort of optimized in the same sort of pattern as Rust based on a sort of C or C++ structure, you get a lot of that. But the drawback to Julia is it's just a weird kind of language, and Rust is just I like the RU,
Yeah.
whatever.
Hey, Roof, there is because I spent some time in Julia, so there is a blog post. It's hilarious. Like the guy basically explains how you achieve the best performance in Julia. He starts with very beautiful object-oriented, like clear code,
Mhm.
and he says this is slow, and then let's like get rid of this, like let's refactor that, and at the end he gets C++ performance, but his code looks like a Fortran code. And maybe
Yeah.
you should try to look at the Fortran, because I still talk to people. They say it's very hard on the CPU. It's very hard to beat Fortran at pure number crunching. So you will not write like a web app in Fortran. You would not write like any control system. But if you're doing pure like number crunching, the Fortran's probably the best still. At least try
Yeah,
it.
I think the takeaway is this. Rust is very strict. And in some ways the most strict of languages. So when you're starting and you're trying to build monolithic things, a whole bunch of stuff all at once in a complicated application, and you're like, I'm going to spend days trying to sort of optimize my compilation because everything's kind of breaking because it's so strict. Now, when you take the approach that I've taken where I'm creating a whole bunch of modules, and that latest one where I showed you the OS pipe and the quantum and DNA that are all very compact modules that have dependencies on all the other modules that I'm sort of plugging in like Lego building blocks. And I know those all work. They're already compiled. They're already functional. So I don't have to worry about those at all. I'm just kind of plugging them in. So now I'm working on little tiny sort of modular additions that I can debug. But once they're done, I can with a high level of certainty say this works exactly how it needs to work without that sort of permissive problem you get with Python where it's like you said it works, but it's totally fake. Yet it passes and it runs, but it doesn't do anything, which is a common vibe coders issue, especially with Python. You're like, apparently built the world's best AI system in Python, but it actually doesn't do anything, and it was just an elaborate ruse that the AI told me did work, but didn't. That problem, although it's possible in Rust, obviously, is much less likely given a nice structured ADR and research information.
True. Yeah, just try Fortran, because Fortran is actually very strict by being very dumb. Like, because you don't create bunch of objects on the fly. You don't, because you basically pre-declare all your matrices ahead of time, and that's why it's able to like optimize very well, because things don't change. Like it's very kind of static. So just, but it only works for like very like number crunching kind of tasks. Like, so if you want to.
Yeah, it makes me feel like we're going back to the 1980s or something. But yeah, so it says, according to Google here, it says that Fortran's a dominant force in high performance computing. I don't know if that's
It is,
What
yeah. That's
about
because it's very hard to beat. I've seen people trying to beat it, and as of like 3 years ago, nobody
it's
beat it. But
it's
it's very
procedural.
specific. It's very small. It's very specific tasks that it like shines. Like it's like you would not
what
write a
about
web server in
using
Fortran. Like
what about using Carbon? So Carbon is a new programming language designed to be C++ successor. It's currently in development, but what if we use Carbon? Currently, you can actually look at the GitHub repo. It's being actively developed, and maybe you can use the new Carbon language because Carbon it builds on C++, which is of course high performance, but it adds additional things to C++ to further improve it and modernize it with the new
Maybe.
functions of programming languages, which should be available, especially to languages like C++. So they're trying to basically make this new programming language Carbon, and it's interoperable with old C++ code, but it also has additional whistles. So
Well, apparently, according to Google, it's not production ready and won't be until 2028. So I don't know, like why are they moving so slow? Like here, hey Google, build me a better version of Carbon. Go. I don't know. They're probably old school and they're going super slow. So that's it. Interesting. I think the Fortran actually is an interesting concept. Maybe I can wrap Fortran in Rust or something. Uh,
Yeah, I mean, with
But I
Fortran,
think you can
at least
Cabo, you don't
everybody
need
knows
to.
it runs
Yeah.
and it works. Yeah, there are other initiatives like that. There's this thing called modular or something like that. That's an evolution of Python that's actually compiled and supposed to be 1,000 times faster. And that's great, but it's still not production ready. So it's an academic discussion as
Well,
opposed to Fortran.
the way that I do most of my stuff is in two forms. The most powerful distribution mechanism I have is something called Nappy RS. Now, what Nappy RS allows me to do is basically replace the runtime within the Node.js environment with my own Rust-based system. And that is the primary sort of, so when I'm doing like super fast things that I need to include in like Claude Flow or one of my npm packages, I basically compile, and I don't want to use a WASM because I don't have like native access to the CPU or GPU or other sort of components. I'll actually compile it as Nappy RS. And this, according to this, acts as a bridge allowing you to write performance critical logic in Rust and call it directly from JavaScript as a native module. So I think what Carbon is trying to do is some variant on that, first of all. So why reinvent the wheel? This works and it's amazing. It's so if you're looking to do sort of high performance, that's at least high performance in a npm structure, which is basically what I'm doing. You can delegate CPU and tasks. You get zero overhead. It fixes all the problems you get with the V8 engine. And that in essence is the trick. That's how I'm doing all the crazy things that I'm doing. So when you go into my libraries and you see the various root vector compilations specifically for the graph and a few other things where I need really decent speed, I'm using this approach. Then when you use Claude Flow and you install Claude Flow or whatever, you don't even know you're getting a Nappy RS and I'm replaced the V8 engine with something else. It just kind of magically happens and it just works across every platform because I've compiled it for Windows, Linux, Mac, and whatever. So it's kind of a cool approach to doing it. Taking a step further, to Vlad's point, what we could hypothetically do is integrate like a wrapper for Fortran and then expose Fortran, I guess, foreign function interface using the Nappy RS, and that would give us native Fortran capability within Node.js. So then I can do like a math library or something. I'm just randomly thinking through it here, and then have that operate in the same way. It's kind of interesting.
Wait,
Yeah.
I
So
just got another idea. Why don't you actually make a wrapper for every programming language in the world and then essentially make a universal programming language?
well, why bother?
Hmm.
Claude is my universal programming language. The universal programming language to our favorite vibe coder, I think he said it, is English, right? That's the universal language now, and the universal interface is something like Codex or Claude Code or some variant on that style of programming. I don't need to describe my problem using technical syntax, right? I can, but what I really want to do is describe my problem in a way that is meaningful to the problem in which I'm trying to solve, right? Which, as an abstraction, English or some, spoken language is probably or written, I guess, language would be the optimal programming language from that. Now, the drawback to linguistics for programming is syntax. There's ambiguity in the description of what you're trying to do and how you're trying to do it when you describe it through language.
Yeah.
I don't know if that
I noticed.
going down a rabbit hole. Yeah.
I noticed weird thing about you say English is the language. So there is two things. So when I show my wife like my prompts, right? She said she's an attorney. She says this is not English. This is like looks like program because you have to be very precise. And I discovered the problem recently. I work a lot with French and Italians. So how they use English? Sometimes they use not very common words that's spoken in America and Canada. They still exist in English. They have they think what it means in Italian, it means the same thing in English, but it doesn't. So, for example, instead of read, they look review. They say review, but because it's the French kind of word for reading. But it throws code out of like Wazoo. It starts doing things not what they meant. Basically, so it's like
Yeah.
interesting.
Well,
So it's kind of made for like American kind of software developers, how would describe the problem, but it's
well,
not.
for sure. And so the question, maybe the question is it easier to learn a syntax of a programming language, or is it, which likely is, or is it easier to learn English? I would probably argue it's easier to learn the syntax of Rust than it is to learn English, which has all kinds of ambiguity. You know, I read, the other day, kind of language, why does it sound the same but spelt differently kind of stuff, or spelt the same but means different things in different contexts, which English is famous for doing, right? So I can imagine if you're, speaking, or reading a different language that's not even based on the alphabet, it'd be even more tricky, right?
But it's actually trickier for people of European things because they very close to English, but there are some words they use commonly that these words exist in English, but they don't mean the same things. So the very good example is embarrassed. Like so in Spanish it means something completely different. Like but there is a word embarazada, like which I mean you can look it up what it means, but
it doesn't
means
mean the
pregnant.
same. Okay.
Yes.
Oh,
Pregnant.
I mean,
Yeah,
that's a common like thing. That's
yeah.
Those are called false friends in French.
yes, exactly, and
The faux amis.
yes, exactly, and somehow French and Italians always get tripped by them because
Actually, that's a good point because now that I think about it, so even in Japanese, for example, we have English loanwords. So the Japanese have taken some English words and have put them into katakana. So Japanese uses three systems of writing. So one is romaji, one is katakana for foreign words, and the other one is kanji. And so katakana is essentially just the English version of a word, but it's kind of in Japanese pronunciation. And a lot of the English words that they take on, although it means something in English, once it turns into Japanese, you kind of have to remember the Japanese meaning of the English word because it kind of takes on a life of its own. And then if you actually go to Japan and speak to Japanese people, sometimes they'll use these English words and you'll hear the English says like, oh, do you mean this? No, it's totally different, which is it's quite interesting, but at the same time, kind of weird as well that it's kind of taken a life of its own. So I can see the point that you're trying to make.
I think it was the reverse with European, with French and Italian. It's like hundreds of years ago, the English borrowed Latin and French words, and since then the original meanings have changed. But English still like uses the old connotations of these words, like, and it's.
Yeah, and that's the question. I maybe I'm biased because I speak English, and
I think every way you approach this, I don't go for Alexi's approach as a programmer because I was never trained as a programmer. So I speak languages of humans. And the body of people that speak human languages, as opposed to the body of people who are quite familiar and fluent with code, is dramatically smaller for coding. So it depends on how broad an audience you want to reach. If you're going to want to reach most of the people in the world, then at least one human language is probably a lot easier way to go about it than trying to refine in a coding sense how one is able to address a coding problem through an LLM. I just think that's backwards. I think kind of the way Ruve is coming at it is let's throw it against the wall, see what sticks, and go from there. And I think that's producing enormous results. That's my view of it.
It seems to work. Like when you look at what a lot of what we're doing right now, and there's obviously folks who are anti sort of Claude Code or that approach to sort of language-based development, and they're saying you can't be explicit, you don't know what's being built, it's obfuscated, and they're not wrong. All those things are true, but to John's point, the solution to almost all the things they're saying that are wrong, like I don't know what's happening, I can't prove it's doing what it's doing, and all that, is more language to create structures that tell me and explain to me in a way that's meaningful to me what it's built, how it works, why it's different, why it's going to benefit the things that I'm doing, both personally and professionally. And that's it. That's conversational at this point. And if you had asked me to do that 5 years ago, I couldn't have built half or probably most of the things I'm building today. And more importantly, if I didn't understand it, I probably would never understand it. I just would reach a point where I'm like, I think I get it, but I'm not sure, and I'd move on. Now I can say, well, no, explain it to me in a way that it's meaningful to me. And now if I speak French, I think I could say, explain this to me au français and see what that says. And the interesting thing about these language models is they're capable of, an emergent property of translating things from one language to another when they weren't explicitly trained in those languages, which is also quite an interesting feat in itself.
Exactly. And I want to add this point that the language is very important. There is those native people that you take anyone, you close his eyes, you put in a dark room, he can tell you where is north or west, and they try to try to understand why they can, even with closed eyes in dark room, they can know where is north, and they study their language, and in their language, to show something, they say, for example, the car is in the north of the house. This is their language. They use always.
Like a
They
map.
they map in their language. So my point.
Although to that point, I was in Bangalore last week, as you guys know, for a couple days. I have absolutely no idea which, other than looking at the sun to figure out, east and west. I had no idea where north and south was. If you would close my eyes, I'd be completely. I think you need some familiarity with the location in which you are, which
Exactly.
speaks.
Yeah.
Which speaks to some sort of internal guidance or mapping system that exists within you, I suppose.
But Rolf, here is another crazy idea for your project. So what if you bypass all language completely and you use the brain waves as an input to LLM? I guess you need to train the models for that.
I got that. And yes, that was my son, Finn. He's ordered something, and I'm always a little concerned when about this technology, but there's a brain, it's probably an EGG, I don't know, whatever the brain
Yeah, the
signal you can
EEGs,
get
right?
from proximity. Yeah, you can get those on AliExpress now for next to nothing. And what the key to what my systems do is signal analysis. It learns in proximity to the signals it has the ability to see, whether that's a Wi-Fi signal, a network signal, a brain signal. And then, and this is the emergent property of the system, without really any guidance, it's able to discern what those signals mean. And they can take those signals and say, well, it's out of the ordinary or whatever, and then correlate those without me guiding it to say how that correlation works.
I think it's not like you'd be thinking. You have to train yourself, because the reason I'm saying you, somebody proposed me the way to type basically without keyboard, because people can train themselves to emit like a certain brainwave patterns. Like so you basically you train, you like kind of like put your brain in a state and say like this state is an A, like, and this state is a B, like, and then you basically you have to both train the model to recognize you, and you need to train your brain to create the certain like electrical patterns. Like it's and how you create electrical patterns, you basically have to look at the graph of the EEG and basically think certain ways, or like kind of concentrate, and you see like when I'm kind of start like pushing my brain this way, like the curve changes this way, like, and that's like how you develop the symbols, and that's you get the whole interface, like, so that's
Yeah, it's all possible, and
and you have an advantage because you don't have a lot of hair on the head, and EEGs work better, like, because they have to stick, like they have suction cups. So you can
Yeah,
just put
it's
it on without anything like that.
well, there's two things we can do also. We not only can we read the wave and patterns. Remember, we especially with these chips and systems we're doing that are operating significantly faster than the brain waves and the signals themselves. We can then intercept and potentially, signal back. Right. And remember the other day when we were doing the bird system, that was essentially just a signaling component, right? Were we actually talking to birds? No, we were basically decompiling a kind of rudimentary signaling component that the birds have created over how many long they've existed. And then basically saying based on these signals, there's a correlation between whether it's a raccoon or a mailman. But so when you think of it from a signaling point of view, most likely there's some form of signal that we're able to dissect, and then once we understand the signal, interrupt and send back. Now, that's when it gets dangerous, right? If we can interrupt and send back, what's the causal effect of that? And I don't know if I want to be the guy to start mucking with my brainwaves.
So it persists. We had the experiment in the hospitals because now for EEGs, for very precise ones, they actually embed the electrodes into your brain. They drill like little holes and put in there. So if you don't read signals, if you start sending the electrical pulses there, it has effect of like psychedelic drugs essentially. Because we had one subject, he said like he was like very avid user of all the substances, and he wanted to take the whole thing home because it's basically having like psychedelic drugs without the drugs.
Yeah, and there's hypnosis systems. I was one of my posts on LinkedIn was banned for that. Yeah, I was about 2 years ago. I created a system that would basically hypnotize you. And and then I put it on there and I played a little video and actually LinkedIn took it down. They were not big on the hypnosis AI. But the reality is it's trivial to create at this point, to create things that both stimulate your, various secondary senses, to create trance-like experiences and other sort of, components that are tuned explicitly aligned to your particular physiology. And when you start looking at like what Martin's mentioned about Muse and other sort of inputs, or what you're describing as like brain things you can put in your head, and then you start correlating both visual stimulus, auditable stimulus, and then the sort of wave patterns that you aren't even aware of, like things that are going to be transmitted back into your brain potentially. And playing with all those different pieces, you can start manipulating your own sort of senses. What some people call it transhumanism, I think. It's probably pretty dangerous, I would guess. I'm no expert in that area, but it's
It's not
100%.
it's not dangerous. I know the math behind it. If you have any question, I can tell you what math you can use for that.
Well, Bibi, you're going to be our guinea pig on that one. I'm not going to.
No,
I'm not going to start hacking on my brain.
but
Maybe I'll put in a chip someday when I'm old and can't think. But
I
until
think
then,
my point here, a knife is dangerous. You can cook with it. You can use it for cooking, and you can kill. It's same concept. You know what I mean?
well, I don't know if knife's the good analogy. It's more like I've got a piece of radioactive, and I could build a nuclear power plant, or I could, die of radiation poisoning. I suppose both are possible, but if you don't know the effects, it's still kind of
Yeah.
dangerous. I don't know.
But you can build a nuclear power plant and die like in the process of building all it also. Like that's
Yeah, exactly. Oh, see you, Rob. Yeah, if anyone's got any demos they want to do, we're definitely open to any kind of demos that you might want to show this week. This week's been a little loose. We're having our philosophical conversations here. Um, there was also some comments on the DNA. I spent a lot of time on that yesterday. We can jump into that. Is there anything anybody wants to cover in particular?
I mean, I've been working on a tool. I was gonna show it next week.
Sure.
I mean, it's half baked, but I don't know if you give me 10 minutes, I can maybe cook up and see if it's gonna work like it's.
Okay, yeah. Half baked is the best baked, if you ask me. If it doesn't
No,
crash
I mean the
halfway
problem with
through.
it, because it works, then I break it and then I fix it, and then I said I changed something else, and then. But let me see, if you give me like 15, 20 minutes, I can like get it ready, like, and then.
We
I
so
wanted to pick your brain here, the group that there is this momentum now. Many articles are being published about the future of the elites and the politics. That the language models will wipe out um, the ruling elites, and there's no future for humanity. There are many articles are being published. That this guy on Twitter went viral with the article, Skumer, or how
that was
it's
a that
called.
was next level stupid. I saw I saw that article.
60 million views.
Yeah, what's happening? Like you got the Molt bot or whatever the hell they call themselves, Claw, which is I guess a gimmick of some sort. And you get this guy saying that the world's going to end because a language model is going to be able to do everything, which we've already discovered is highly unlikely. Um, yeah, I think he's spending too much time, watching sci-fi movies and not actually building things. Is the first opinion I had there. I don't know. Anyone have any other opinion? Because as far as I can see, the AI that I'm creating, which is extremely capable, building DNA systems on a whim while watching Game of Thrones, it says but I don't get the sense that the thing's going to run away and destroy humanity. I get the sense that it's going to improve our lives by giving us the ability to do things that we weren't able to do before, democratize things like health and legal access and
Agree,
things
yeah.
that were only limited to elites, to everybody else. And back to BB's comment, a knife, it can be used to you can kill someone, I suppose, but it can also cut food that you can eat and be healthy and sustainable because of it. So yeah, do you have that article handy? I read it the other day.
Yeah, I've got it. Yeah, and all the joblessness reports that okay, in 1 year, 80% will be unemployed, and all these kind of news is really
That's a byproduct of the financial system. I think it's we've got a system where tech workers are numbers on a spreadsheet, and they don't think twice of firing 20,000 people in one go, and then for why they need them in the first place. But
maybe the signal here is that people are receptive to these narratives. So maybe this is how most of the people are wired, that this negative narrative is very, very receptive because they don't really hear too much. This is why I like, for example, this Moonshot podcast that we talked about.
yeah.
So maybe one idea could be that let's kind of provide more information about the upside, because most of the movies, everything is about kind of like the negatives in most of the cases.
All right, so let's just look at this. Something big is happening. I'm not arguing something big is happening, and you can see collectively the people I'm working with, the things that I'm building, the things we're building collectively are just mind blowing. But the other part of the oops, someone's ringing here.
Sorry, that's me. Sorry, I got mute.
Yeah, sorry, I'm gonna mute all you guys. All right. Yeah, so when you look here at what he's saying, this seems to be bigger than COVID. Okay. We should be about where he works in AI. I know it's because it happened to me first outside of tech. Okay, for years I've been improving. Yeah. Need for actual technical work in my job. So I think this is a fundamental story. He's saying because anyone can do it, therefore it's going to destroy all jobs. Now, on the flip side, when you got computers, did that mean that suddenly because we were more efficient and effective because we had computers, there was suddenly less jobs to be had because people were more efficient? No, that's not what happened. People had more jobs. They were just different than the jobs that existed before computers existed. Then the internet pops up and everyone's like, oh my God, the internet's going to destroy all the jobs because information is broadly available. And you're not going to need information workers anymore sitting in front of computers. Well, no, that didn't happen either. What we ended up doing is having a whole bunch of new companies and new jobs that employ substantial amounts of people because of it, because they realize that you still need people in these companies to do things. Now, those jobs within these tech companies, are they going to be the same? Are they going to be me sitting in front of the computer doing, menial work? Maybe not, but it means that I can do a whole lot more quickly, and that likely means that the jobs are going to change. Now, there's probably a dichotomy that exists between those who are naturally curious and inquisitive versus those who are lazy and do the most minimal viable effort to get by in their existence. But that's human nature. There's always some portion of the population that's lazy and doesn't want to work and doesn't want to put in any effort, and that's never going to change. And those people, just to be honest with you, have never been successful really anyway. So if you look at agentic engineering, we're catering to a group of people who are now empowered by this technology to do the things that they never thought they could do before, to build those things that they never thought they could build, and become more than what they were previous. And I think that, for me, is really exciting. And that's the portion of the population that I'm mostly concerned about. Now, the on the second side of this, if that becomes a thing and you've got a separation of the extremely capable with the sort of lazy group of people, maybe it's part of our I don't know what the right word is, obligation to support not just those who are empowered, the technical elite, but everyone else along the way as well. And maybe that's through forms of socialism that provides means and access and money and food or whatever it is they need to survive in that world. But that's a byproduct, I suppose, of being super capable.
Well,
Anyway,
to be fair to that guy's article, though, just skip all that stuff in the middle if the alarmist tone bothers you. Go to the last paragraph, and this is where it gets cool. He says, instead of dismissing AI, he's talking to the common people, not us, right? Who haven't experienced it. He says, instead of dismissing AI with fear or saying it hallucinates and it's worthless, spend $20 a month, get access to the latest models, try it to accomplish something meaningful, and see what it's like. And I thought that was really what made it a worthwhile article, was that last couple paragraphs.
I think the thing that's happening here is the mode is changing, right? There used to be a mode around having a college degree and what jobs you can get. There used to be a mode around the technology, that your technology is so complex it was too hard to duplicate quickly, right? We just did a decompiler in Rust in 2 weeks of continuous coding. The CUDA mode was done in 7 hours. And so people are realizing that what they thought was a moat is no longer a moat, right? And pretty much anything that has a verifiable reward can be replicated by AI. Think about all the Adobe products and even 3D CAD or gaming engines. If you can explain to it, here's the input, here's the output, and this is what success is, AI can code it. So what we're moving to is a new cost model, right? Where the cost of the product has to be less than the cost of the hassle of getting AI to build it. And that's what the world is coping with in a month, in 2 months. And, it breaks a lot of business models and educational models.
Well, take it a step further, it doesn't just break models, it breaks, it breaks business models, cloud computing models. When you can put the, intelligence embedded into anything at almost no cost, light bulbs become smart in terms of not just smart, but I mean like intellectually smart. It creates a new sort of way of understanding and seeing the world just generally. I steer more towards Star Trek than Star Wars. I believe in utopia less than dystopia. Maybe that's because I'm an optimist, but the at least me as a microcosm of someone that's become quite capable and doing a lot of interesting things that I never thought I was going to be able to do is I see myself not only being empowered, but I see those around me also empowered, which only inspires me to do more. And I don't know. Ofer, what do you think?
I like that article, Cynical Relatives, because I do think it differentiates between people in this group that are knowing what's happening and adapting already, and common people that are still in ChatGPT, can't count how many R's in Strawberry. And I think it's important for most people to learn what AI can do, because in a few years it's going to get stabilized. But in the next coming years, I think there's going to be so many companies who will think they don't need so many people because things are so much more efficient, until people figure out what that new profession looks like. So until stability, I think that the shakes going to be massive for most people.
Yeah. Scott?
I was wondering if anybody's like, is there any like AI thought leaders, like an LLM on like X or Twitter or whatever, that's posting stuff that anybody's like actually listening to? Like, is there any like artificial intelligence putting anything out there that people are following? And I think when that happens, we kind of reach that point where it gets scary to me.
Yeah.
Because like people like Kirkpatrick, they have reputations that they can only really build in the real world through living. And I'm not yet seeing LLMs
Oh, you're talking
producing stuff.
you're talking people or AI?
I'm kind of when are we going to start getting AIs that start going on Twitter, start posting stuff and creating a following around themselves?
Well, I don't know about the following, but what I can tell you is every morning, and I get up and I see these crazy things that Pulse is suggesting that I implement. And some days are better than others, and it's dead on. Like the stuff it's giving me is just mind-blowingly amazing. Like it seems to know me better than I know myself. It's super nerdy, in fairness, but like if you look at the breakthroughs, I would never have thought to explore dynamic min cut. Like I had no idea before December that dynamic min cut was even possible or a thing. And one day, Pulse tells me, based on all the stuff you've been building, you should really check out dynamic min cut. It's going to change everything. And you know what? For me, it did change everything. It suddenly meant that I could compute, the space in between in real time without having to recompute the whole entire thing. I suddenly am working in nanoseconds for things that were taking minutes or hours previously. So like here's another one. Like it knows, oh, here's a quantum problem as a vector space. Like you guys heard me talking about this earlier. Like I'm literally into this right now today, and it's telling me here's what you should do to take it further. Right? It even gives me an ADR. It
Do you
knows that I like
trust it?
ADRs.
Do you trust
Right?
it because it's coming from your ideas? Like
Do I
it
trust it?
has like
No, I don't. I don't trust it ever. But what I do is I then explore it. This is a jumping off point. Now,
yeah.
Depending on what I want to do, I might just grab this blindly and start vibing with it. This one's an easy one because look, it's already given me the packages. So it's saying, here's the packages you need to create. Here's how it integrates with your existing components. Like it's done the first step of the sort of, this is something that's breaking and cutting edge, which is pretty cool. Now, if I go up here to like the most cutting edge stuff that it's giving me, it's like literally giving me a 200-word opinion because I don't want to read too much, right? I
Yeah.
just want to. I never told it to give me a 200-word overview. It just discovered that I have a preference towards 200-word overviews. So here's Ripple Plus and Go Vectors and Stag and stuff, right? So now all I need to do is copy this, go, give me an ADR, and I'm one step away from getting it built.
And I feel like that it's building off of your stuff. It can have a dialogue with you that you'll be interested in. And I'm wondering, like when I do it, it's like I'm interested in what it's saying to me because I'm inputting stuff to it, and it's giving me ideas that build on mine. And I'm like curious when it's going to get so generalized that it can speak to multiple people at a time and hit kind of what everybody's thinking about. Like people who are leaders.
I think it's already doing that. You probably don't even know it. I think there's probably blogs that you read that are entirely AI generated and you have no clue. But I think the biggest challenge here, and I wrote about this before, is what do we trust? What is the entity that we're trusting here? Because it's really not an entity. It's an instance of some LLM running in the background that loaded some context from you and has no vested interest in you other than what it's been told to do. And it doesn't really persist over time as a thing that I could trust. And that's my core issue with like trusting LLM with my, any of my accounts, really, like even my email, because you can change all my passwords if you have access to my email. Why would I do that? So it's like I don't get I think that's a core problem in this whole thing is trust. And the other core problem is still AIs can't distinguish between instruction and just conversation or text, right? So if I can inject something evil somewhere in any bit of text, anywhere, I can get the AI to do evil shit. Well, that's a terrible weapon. I got a board of PhDs that can do anything by someone injecting a line of text to do something bad. That's talk about your attack vectors. That's horrible.
And a person could, reason about that and say, I don't want to do that, or I don't like what that's saying, where the LLM just kind of listens.
The LLM should never be the primary source of reason. It should be the last source of interpretation, but it shouldn't be the component that grounds your system into. I think we were talking about the other day the idea of a constitution, or having anti-drift capabilities, or having the ability to understand comprehension, coherence, and other components. Those should always be mathematical, right? Those should be based on some form that is explicit, deterministic, and not in a form that can be interpreted. And that's the fundamental issue with language models for having a kind of prompt-based driven agent. If your agent is nothing more than a skill and an MD file, well, you've already failed.
Hey, Roof, that's what I was going to present. Like, I'm ready now.
All right, let's see it.
Okay, let me share. Do I need permission to share? Or
no, you should be good.
Okay. Where's the share button? Hold on, I'm blind.
Big green one.
Oh, share, big green one. Okay. Jump around. Okay. And we go here, share. Okay. So the problem I'm trying to solve is exactly what you were saying. It's when you ask LLM about facts, sometimes they give you correct ones, sometimes don't know, sometimes they can search the web. So the one thing I work a lot with biology, and there is a lot of biological knowledge is actually captured in the knowledge graphs. And by knowledge graphs, it's the original kind of knowledge graphs, not what that Neo4j is trying to push up. It's the old RDF graphs. So one example of the database, it's called UniProt, which used to be called a SwissProt, and it's so if you see, they contain 500,000 information about the 500,000 proteins that been human reviewed. So somebody has actually looked at every one of these proteins, and they have 200 million proteins that they just know about. They have not been human curated. So usually that's the reviewed one. They get a PhD who spends a day on one protein, make sure everything's right. The other ones, they come from different machine learning, things, right? So I developed this tool. It's called Sparkle Clee, and I also was making. So the purpose of it is basically to be run by Claude. And I also have a skill in agent. It's not in this repo. I probably shoot it there. And that's how this session looks like. So while you've been talking, so the session did not exist 10 minutes ago, right? So let me go to the beginning of it. It's actually when I initialized that, basically say we're going to so somewhere here, right? It says right here, basically it explored it was connecting to knowledge graph. You just basically say you define your profiles and you connect to databases, put credentials. And then it can, when you ask questions, it can actually go and make the queries against the database. So the database I'm using, that's my other open source project. It's a Pokemon knowledge graphs. it's like things we connect it to knowledge graph. You can ask questions about the Pokemon. So basically, it knows about 807 Pokemon species. One thing about my own Pokemon knowledge graph, it's actually, I intentionally corrupted it, that it contradicts the common standard Nintendo Pokemon. So like some information I edited to make sure like when I ask it questions, it gets it from my database and not from like some like sources like external, right? So then you can ask like, so that's what it knows about. It knows about 807 species, 747 things. And then when you say like which Pokemons are green, right? When you ask that, that's actually, it goes and it makes the it makes this query. So if you can look, let's see if I can, yeah, and this is, it gives you a list of the Pokemons. Let me see. Yeah, so we can actually ask it. And ask it how much the Pikachu weight, right? So this says the Pikachu is 100 kilograms. So there is another knowledge graphs I used. It's called QUDT, which is stand for quantities, units, dimension, and types, I think. And it basically says Pokemon is 100 kilo. The Pikachu is 100 kilograms. So anybody knows other Pokemons? Which Pokemon is under 20 kilo, right? So you ask the question like that. So, and there isn't, so it doesn't go search on the web. It what's it going to do now? It's basically, it created a database query like that, right? It's
Ask it for Magmar.
yeah, Magma. Okay, I'll do it. Yeah.
I don't know enough
let's
Pokemon
see. Yeah, let me see. Let me go. So basically, you see, like when you ask questions, it doesn't. It's basically, I asked which. Oops, what was the question? The question was which Pokemon is under 200 kilograms, and what it did, it actually, it goes, it creates a database query basically, right? And it says like filter me all the Pokemons under 200 kilos, like, and so which one you who ask about whom?
Yeah, ask like Magmar, but the yeah.
What
Let's see if there is Magmar.
Dollar Magma MAGM
Magmar, yeah, like that, I think, yeah.
Okay. Yeah, and that's basically, it's a tool. So it's, I use it more for protein. So it's basically, and that solves the problem of all these hallucinations and stuff, because Claude and most of LLMs, they know very well. Actually, people don't know about the Sparkle language, and all the large language models, they know like lots of different programming languages, and but that basically doesn't, it's up to date data. If I go to knowledge graph right now and it's just change the record and says Magmar is green, like it's going to answer Magmar is green, like, so that's, and yeah, so when you ask yeah, what color is Magmar, that's what the query is it sent.
Nice.
And yeah, and I linked the it's in the chat, the link to the tool. Yeah, if you give it a star, like, we appreciate it.
Cool. Yeah, I've been playing around with some RDF and ontology. Do you know Kingsley? He's the our guru on the sort of semantic web. He's been doing it for like 25, 30 years. He's the one who pushed me towards using Sparkle.
Yeah.
So a lot of stuff I've integrated recently is Sparkle based. It's
So
smart.
Cool thing about, so Sparkle and Spark, there is no confusion, and then so the cool thing about Sparkle and RDF is that they have ontologies that are encoded in very precise language. So it doesn't, so the reason it can make very good queries, if you pointed to SQL database, it would not know like a lot of those, like how to write the queries as good, because Sparkle databases have some called ontology. It basically describes what classes are there, how are they related. It's very rich language basically, and it describes the semantics of the underlying data. So if you ask like what color is something, and you can ask is there conversion to red. So it's actually one I linked a little bit of Wikipedia because the graphs, they yeah, it's actually so there is something called DBpedia. It's essentially Wikipedia expressed in this RDF dataset. Like, so if you say like, what's the cultural meaning of red, it's actually going to go and look like what it is like. And so the red means heat, danger, and anger. Like, and it's sometimes actually I'm trying to learn Turkish, so it's like something like ignore the Turkish phrases there. Yeah, but that's basically so. Yeah, it says because it's being red, it's a heat, danger, and anger. Like, so that's the yeah, and it's the way like you can link ontologies. So like if you want to link. I did not load the protein database there. Maybe that was my actually thought is what I can do with this knowledge graph is maybe this week is you go and look which proteins express the coloring of the skin. And then you ask what's the like the magmar, like what gene does it have like to make it red, like, and then you can actually create the DNA profiles of the Pokemons by linking the Wikipedia, the Pokemon database, and the protein like databases and genomics databases. Like,
This is hilarious, Vlad. You have way too much time, but it's cool.
Yeah. It's
Evolve
great.
a new Pokemon.
no, it actually that whole thing was written. It's not. I do not have too much time. I have like no time. This was written by Claude. I spent like 3 hours on the whole thing, like of my own time.
No, it's
I think
like you're
another
thinking.
thing I think another thing you have to explain is what is that display you're showing, because this looks like a Hercules card attached to an XTPC.
Okay, that is because everybody's going retro these days. So this is the project called Cool Retro Term, and I'm not sure how well it goes over Zoom, but it is the Hercules card, and because everybody's going retro, so you can look at as the
Yeah,
like
you
IBM.
you can't go more
The
retro
green
than
one, yeah. That
Yeah, no,
reminds
and
me
you
of
can
my
actually
answer CPC.
you can mess them up because it's actually this terminal. It's Jamie Zawinsky, I think, or I don't know where it came from. Like, it uses GPU to emulate physical CRT, and you can actually get the real problems. Like, so you can put static noise here, and
This is like the ATM
I
machine.
think I think
then you can get the bloom. And it's actually it says so when you do it and when you type. No, so there is a effect that CRTs have that that the bright colors they get this what you call it
Glow.
the glow, yeah, around them. Like, it's not the glow, I think it's
Yeah, the
called
bright colors
bloom.
fill in the lines, the raster lines, so they appear more solid.
Yeah, so and then you can I think you can get jitters, so you can I tried to work like this if you want to look like really retro, like
Oh my God. I was like a radio television technician, in the high school. So,
I think this is
so you
CRTs,
can
bring
actually you
some
can have
memories.
terminal like that.
I think this is one of the better applications of GPU that I've seen.
It's awesome.
This
You
project is pretty old. That's actually I think when GPUs came out, this is like, but this is exactly so you can understand how the televisions work. Like,
well, it's 12 years old, according to the
yeah.
GitHub repo.
Oh, actually, so I used Claude to hack on it because I got Claude to analyze it code, and it actually I added two feature. It supports Unicode emojis, and it also you can click on the links and it opens the browser. So it's the CRT with the CRT problems, but you can like click on the links like in there.
Okay.
And
Well,
this
put
is
it in the
even
chat.
sorry.
Put a link in the chat.
For what? For the
It's in there.
Somebody
The
already
GitHub.
put it. Yeah.
No, I put a link to the tool. You mean put a link to the terminal or to put the link
No,
to
to
the
your,
Yeah,
The
it's in the
terminal.
chat. Yeah, to my thing is in the chat. If you want a link in you can if you have a Mac, it's called Cool Retro Terminal. Like, you can just brew install it. Like,
Okay.
Imagine
Yeah,
this is
and-
reality for some companies in finance. ATM machines are still the same.
Yeah.
2016.
Yeah.
Sorry, 2026.
Yeah. No,
Yeah,
but it
it's
seems like everybody's going retro, so that's my kind of paying homage to it. Okay, that's all I had to show. Like, I'll put the link to the cool retro.
It's built in C. I suddenly have the urge to just port it just because I can to something else, but
You can, it's actually to hack on. I mean, you can port it, I mean, share. I think what I wanted to do, because the terminal sucks, because there is a library called Qt, and the Qt has the terminal widget, and they just basically they put a GPU render, like, so basically they run the terminal widget inside, and they grab the images and they apply all this like CRT effects on top of it. So I was thinking, like, if you have like spare code cycles or anything, you can basically take the image processing routines and apply it to some like better terminal.
do you guys want to see how I'm setting up my automated patent creator?
Sure.
All right, give you guys a crash, and this is a private project. I'm probably not going to publish it, but it'll give you an idea of how what I do to set this sort of thing up. So so I haven't built it yet, but what I'm doing is I spend more time often on my sort of ADRs and sort of PRDs than I do on implementing, because that's mostly automated at this point. So in this case, I'm looking at my various key sort of repositories, the most popular ones. And then what I'm looking at is the ability for it to find potential patents that fit within the sort of framework of the last year that I can hypothetically file. But I want to make sure that I don't spend a whole bunch of time creating patents that aren't going to be accepted, right? So I need a system capable of looking and understanding, assessing that these sort of patents don't have any prior art, that there's a novelty to them, and ultimately the actual person is going to accept them. Somewhere someone's going to have to go in and say it's valid. So then, I gave it some initial guidance that I wanted sort of a multi-step phase. I had an initial sort of structure that I created an agent. What was an agent? I think it was a skill that I called patents. So you can see that I got some skills in there, and that was sort of the initial sort of jumping off point. Then it's looking through sort of an enforcement. So I'm storing all this information directly into a embedded, space. So I'm using my tool to create the tool to do patent based on the tool. So a little recursion there. So I'm looking at things like Roofan and others that we might be able to use over the last year. Then there's an assessment, subject matter, novelty, non-obvious. So what's being created at this point is essentially a combination of things, right? So we've got this pretty in-depth ADR that sort of talks about how it needs to learn and how it needs to understand, how it needs to do its research. Then what I'm doing is I'm using sort of, I created a series of scripts here for agents and pipelines, but these parts, the claim drafter and the learning and the optimization and all that sort of stuff, those are actually invoked through a combination of skills, which I was showing you here. So this would be the sort of initial patent skill. So that ties both the agents and the sort of methodology that I want in terms of single patent draft or validating draft and enforceability, how it thinks essentially. So and then enforcing a kind of auto conversion, what's right, what's wrong. So this is the language essentially. This is the guidance. It's a pretty heavy duty skill. Now that in turn links to a patents. Where did I put that? No, maybe I haven't created that yet, possibly. But at some point, oh, here it is. I'm gonna put that into a folder, so I gotta do that. I'm gonna create that new folder. So we'll call that patents, and then I'm just gonna drag that in here just because I don't like a mess. So we'll pop that in here. All right, so now we've got different patents. So we have claims drafter, we've got examination simulator, we got patent strategist. So these are the agents. So this is how the system understands what it needs to do and decision criteria, similar to what you saw in the ADRs themselves. So examiner simulation. So I want to simulate this, right? I don't want to just do a patent. I want to simulate every possibility of the patent, and whether it gets rejected or whether others have done it, backgrounds, so that's what this is doing. So it's a multi-part sort of stage. Now the part that I haven't done, this is where I'm kind of before, because I ran out of time before the call today. The next part is my second ADR, which we see here, and this is the team memory. So what this does is, now that I've got a sort of structure for how I know and want the patents to be researched and potentially created, I need a mechanism to persist it and learn from it and get better over time. My system has the ability to learn and adapt and improve based on various criteria, which could be synthetic, basically running simulated versions on fake data, or it could be real. I could just look at the patent, all the recent patents on a database that are publicly available and learn from that as well. So what this is doing is basically saying, here's the available tools that are allowing you to do sort of the components, and for prior art, for example, it's going to say, well, prior art should claim similarity scoring, or the GNN, innovation patterns recognition, forgetting and prevention, claim to prior art attention, weighting, relevance scoring, right? So each of these are different parts it's going to use for different parts of the sort of patent learning structure. Yeah.
Yeah. I sent you a link. I'm not sure you're familiar with. There is a data set. It's Patent Office publishes. It's called PTAB, called Patent and Trademarks Appeals Board. So you can actually see the communication, the case, how the patents I think even rejected.
That's exactly what I'm using.
Oh, that's because that way you can bootstrap your learning. Because do they have rejected patents there as well? Or
I'm learning. I learned. So remember, I'm using MinCut, which is the rejections and the things that weren't successful are actually for mostly more important than the things that were successful. So I'm actually more interested in why and what was rejected. Was it rejected because it was an individual who has a tendency to reject things, or was it rejected because there was a missing diagram or whatever?
That's another, but that's, I don't know, it's how legal that is, because I know law firms actually do it using people. So if you understand so Patent Office has something called text centers, that's why and it has the routing basically rules. So if you word your application carefully, you can control which text center it's going to end up with. And some text centers are lazy and they just approve anything they see or reject anything they see. And some are more.
Yeah. And that's what I'm looking to discover. 100%. That's exactly what I'm looking to discover. I'm looking to discover the path of least resistance based on all the variables available to me, and that public data sets mostly, and then training the system to understand and correlate those things based on the particulars of the patent which you need to create. So this is the underlying sort of structure of the sort of understanding, right? So you've got teams and tasks and swarms and memory and learning and simulations. So that you see here, I've got an examiner simulator, right? It's literally trying to figure out where the optimal place to submit it and what the examiners might react to it based on historical data that I can get. It's going to go find and optimize that data. I'm not specifically telling it where. It's open and capable enough to go and do that by itself. Share that learning with everyone, with all the other agents in the system. Right.
How many examiners simulate? Because I'm not sure you can have one examiner simulator because they have different personalities. So there is a lazy examiner.
It would potentially, I could potentially get to examiner level, but mostly it's going to be based on broader characteristics.
Right.
So but that might be my third ADR, right? And as I go through the process of discovery, I need to go and sort of wire additional sort of steps in along the way. And once I'm done and I'm happy with all those things, I will have a system that will be capable of sort of adapting, learning, understanding. Now, what I'm showing you is essentially how just what every legal AI agent to some degree is being built at this point. You're seeing some variant of this, right? It's a multi-stage self-learning pipeline. Right. And so portfolio optimization, and then ultimately at the last stage, you're always learning the patterns to make the next run better. And then when you move from sort of hypothetical, which is where we are right now, to operational, meaning let's say I'm not going to make this a public service, but let's say I was, then what would happen would reality would take set and then you adjust based on the practicalities of the differences between the simulated environment and actually doing the service, executing on different contracts, whatever it needs to do, and then learning based on how it works when it's out in the wild. So this part is particularly important for kind of long running optimization beyond the simulated stages, where right here, these other parts are more like early stage simulations, right? I'm faking it before I make it.
Do you define like the agentics in that simulation part, or is that all being like kind of coordinated
It
by
already
LLMs?
it's
And then
already coordinated. Well, it's not it's coordinated somewhat by LMs, but it's coordinated predominantly by the Claude team and code system that I've devised, which is based on my Ruby LLM sort of learning system. Now
yeah.
I'm just optimizing it for this particular purpose, right? So I'm in the most simple terms, what I'm doing here is I'm just creating a kind of Claude Flow optimized patent review and application creator.
And through doing this on a few of them, you can kind of learn the patent space.
I can do it in all of them. I can do it in every published patent ever created. Take all of them, and depending on, and there was a service I found that gave me not just the final patent, but all the patents that were rejected or the process in which the patent went from application to success. And then I put all that into the sort of vector data. Then I apply attention. I create custom tensors. Now I might use even a quantum structure to organize it with a more rapid min cut. Then when I do a simulation, I can simulate potentially millions of different patent applications and processes, correlate them, and then hypothetically get the optimal path to success based on those. And that entire process takes a minute, maybe less.
So that
I can
optimal
come.
path, is that like, oh, sorry.
Yeah, it's like it's literally what it sounds like. It's so what it's giving me is a kind of map, not just a map. It's giving me a guide, and then as I execute on that guide, the system then can adapt based on the realities that present themselves that possibly weren't thought of. So it's literally, a kind of, here's your optimal future. In this case, let's say I want to have all my patents or as many of them passed as possible. And then here's how you can reverse engineer to get to that future. Now, as you execute on that sort of path, things are going to change, things alternate, and then the system is in real time giving me advice and restructuring. It's like turning left on a street because there was traffic and Google Maps recalculating the path to get to the final location. It's that, but rather than navigating streets, it's navigating, a series of causal effects.
So it's like you're learning the organization that's
The
successful in that space.
anti-organization. I'm
And
learning
what is
the anti-organization. I'm learning about all the reasons why it's likely not going to work to try to find the reason it's going to work and find the point of intersection between mostly the things that don't work to find that one thing that likely will work by applying attention directly to. It's similar actually to what Vlad was showing, where he was showing this idea of an RDF. So I'm using an RDF structure for that as well because it maps really well to patents because it's a kind of structured sort of data set. And then I'm applying attention to sort of learn and potentially a tensor in the flow to optimize the tension of the graph itself. Robert, you got a question? Nope. Did we lose him? Well,
Sorry, no, I just didn't unmute my mic. Sorry. I just wondered
no
how you're
worries.
getting hold of the data for the patents. Like, are you mining it from like public websites or like how are you finding the data sources for
I'm
these kind of things?
Now that LexisNexis doesn't allow you to use AI, which come on guys, that's stupid. But anyway, it's not LexisNexis. Anyway, it's public. You get
Yeah.
a ton of this data publicly. There's a Google has an API. There's a bunch of them,
Wait,
and so
hold
there's
on.
no
Look,
shortage.
actually, I worked in patent office before, and one of my projects was publishing the bulk data. Like PTAB, you can just get it as data files. Like you can just download data sets. Lots of them, you can just get them straight from patent office because it's all public.
Yeah. So I'm getting it wherever I can find it, and then I'm loading it essentially into my Postgre, and then I'm applying all my various tools to find the optimal paths and interconnections and within that data. And this is all happening really quickly. And then I'm getting the agents to go explore my various repos. You can see that I've given it several upstreams to explore. And then I'm sort of saying, based on the likelihood of acceptance, value, and other things that appear to be sort of taking off in the space, what are the most useful patents that I can build and create and hopefully have successfully applied for. Now,
Are you looking at the court cases because that's what because when you get the patent, it's not really guarantee you're gonna have it forever because somebody might sue you and invalidate it. But if you look at the
well, here
patents that have been validated,
let's add additional capability. So that's exactly, I'm early. So you're only seeing, I haven't built this yet, by the way. You're looking at the process I'm going through to eventually build it. So the next step might be just simply saying, we need to evaluate all rejected patents, court-related cases and liabilities.
so they not rejected, they called invalidated. So because it was not rejected, you got your patent actually, you got your certificate. But then later on, somebody said, hey, this certificate is bogus and let's go to the court. And you go to the court and actually what you really want, you do want to go to the court and the court says, yes, this is the valid patent. Because examiners, like they super busy, they spent maybe, I don't know, 30 minutes on your application essentially. But when you go to the court, that's when people really look at it. And if you come out of the court as a winner, that patent is worth of gold, basically. That's the
Yeah. So again, I'm just simple little prompt. We need to evaluate all invalid patents, court-related cases, and liabilities. I don't know. Find all available. Oh, I guess date. It'll figure out that I'm in data. Include data directory with data we can use for this. So at this point, it's going and it's gonna Claude's gonna do its thing. It's gonna go and find me some more data. It's gonna go and create this as another ADR. Now the key here.
Can I just make a suggestion? You have two court things. One is the appeals board within the patent office to see if the process the examiners used was correct. And then if the patent issues, someone else comes in and says, my claims actually preempt your claims, so I win in this context, which is a huge market, which would be in the United States system, the federal courts. So you have two different levels of courts you might want to involve. So you might want to refine your prompt to take that distinction into account.
It most likely will discover those things. Like we don't need to be that explicit. We can be, but the system is, again, it's learning, it's adapting, it's finding those things that are beyond the things that I, as a sort of not a legal expert, would even think to look for. And that's part of the power of the system is its ability to do sort of goal-orientated sort of discovery. So because I've got all these other skills, and that's why I can build these things that are beyond my own comprehension. So when you go into my Claude agents, for example, and you see my goal skill, this is one that is kind of the primary discovery agent that I use. It's a goal-oriented marketing specialist. You guys are probably familiar with my goal stuff at this point, but it uses dynamic planning. So the dynamic planning allows it to sort of traverse a maze when it doesn't have the answers, but it's going to try to find all the optimal conditions to answer those questions, like what John just described. Now, if I know that is something that's important, then I could go down in here and I can just add that to the list, include appeals processes, patent issues, and federal court cases or something, right? Right, and that'll just add that to my list of things it's looking for. But ultimately, this state assessment is what's actually doing the works, right? So it's saying, analyze the current world state, what is true now, define goal state, what should be true, identify gaps between the goal and the states, and then the actions inventory available, deterministic and plan generation. In particular, the A star pathfinding approach, of all the different approaches I've tried to sort of observe and find the optimal path to the solution, this one seems to work the best, at least for the things that I'm doing. And then it's like, okay, how do we actually observe, orient it, and understand it? So that's a kind of introspection. This introspection is particularly important. Pretty much any agent that's going out and answering the unanswerable, which really means answering the things that I don't know, this particular loop combined with the plan works really well. And then ultimately, it needs to reassess. If it discovers or learns something along the way, for example, a website doesn't work, or there's a new law that just passed last week, it needs to then adapt itself to the new reality, back to the first step. The state
Yeah,
assessment
Roof, you
will
just
change.
that's something important actually, because patent law changes all the time, and there could be like a case in Supreme Court last week that basically would invalidate lots of your strategies. So you have to
Exactly.
you
So
have
that
to
is
when you
happening.
look at something, it's a piece of like science knowledge about the patent process. You need to make sure it has not been invalidated.
And that's what this is. This is essentially attempting to do that, right? So it's not just saying how's it been done in the past. Because it was done and successfully done for 20 years doesn't necessarily mean it's going to work now. So and so this is really useful for things that are always changing. So think of like stock trading, for example. What worked last week definitely won't work this week. So you need a system capable of understanding the preconditions and then adapting to the new reality that it sets forth. So it creates a kind of internal world model of sorts that it can then simulate based on the new conditions. Then it goes back into the system, which again I've created some different learning and validation components here that essentially allows it to reassess its own assumptions.
How would you scale that across like multiple users? Like if you had like 1,000 users trying to work on like using this, say, it'd work
Well, so
without.
first of all, I'm building this for me. I'm not going to I probably won't make this
Yeah,
one public.
just trying to think.
But hypothetically, that is why I created a chip, right? So let's go back to the large, healthcare system I'm working on. 50 million or whatever number of patients that exist within this. Hypothetically, not hypothetically, realistically, if I wanted to create agents for each one of those 50 million users, and it's a healthcare related system, I would likely need dozens of agents always running and monitoring and looking. Most of those agents would probably be sitting idle most of the time because not all healthcare patients are actively using the healthcare system. But I also need to have the system capable of being aware and jumping into action when something does happen, an emergency or doctor's appointment, a pharmacist needs an update. So by creating a system that is sort of dormant but looking for integrity system or integrity, I can have these agents running. So rather than $25 a month for one agent, like on a cloud provider, I'm running able to run 100,000 of these things on a single box, looking for the inverse integrity of the system, and then instantly turning on and doing its thing long enough to figure out whatever it needs to do, update a pharmaceutical database, or figure out if someone has cancer, or whatever it happens to be. And the cost of doing that, because it's sparse, spiking, and you're looking at the minimum cut, goes from conservatively 10, maybe $15 a month to 0.00001 cent, because it's dormant. But there's a slight signal, a very minuscule signal that's currently being monitored, or always being monitored, looking at the integrity of that thing that it needs to understand. Now these are narrowly scoped. So when I say there's 100,000 agents on this box, they're not trying to answer all the questions to, is this person healthy or is this person sick? Do they need a pharmaceutical thing? They're looking at very small parts of each of those problems individually, narrowly, and bounded, and then adjusting. And then if something falls out of scope, they will not just awake themselves, they will go and collaborate with other corresponding agents that need to help them through the process. And ultimately, if it's a decision that's beyond the scope of the capabilities of my box or whatever you want to call it, then it might need a higher order model, like a language model or the highest of highest order models, a human. Maybe someone might die if the decision's made wrong, then it might escalate. That escalation is a high latency escalation. That means that the highest order model might actually take a long time to come back to me. So that means a human might take days or weeks to get back to me. While that's happening, the system can again go dormant. It's not just waiting and spinning cycles and on compute or GPU cycles waiting for the answer. It's waiting for that integrity check again. And as soon as that response is received, it understands the integrity has changed, and then it comes back to life again and completes its process. That is the inverse of everything you see in Claude Code. Claude Code chugs away, burning tokens, asking the same questions over and over. Are you done yet? You ready yet? Are you okay? Is it done? Or have you done this? I'm saying that most things are sparse and can be dormant until they need to be executed. And that's the secret of the whole entire system.
Thank you. That's really useful.
Yeah, and I don't think anyone's doing that approach, and it works really, really well for everything other than a language model, right? It works really well for anything that involves signal. Because signals, whether it's a brain pattern, a stock trade, a healthcare system, ERP system, the inner workings of the Windows operating system I was showing you before, those are all signals capable of being min-cut. Once you're looking at the anti-pattern, that becomes light, fast, and ephemeral. So I can apply that inversely to patents. So maybe I have an always running patent monitor that does exactly what Vlad and John suggested, is looking at not what happened last year, but what happened yesterday or last week. And then if something related to that particular patent, changed last week, I'm able to instantly sort of jump into action. So some of that requires a coordinator, and some of that requires the ability to understand when that information changes based on a pull or a push, but most of that doesn't. And that's why it's cheaper.
Yeah, great, because that's really, really useful. I've been trying to work out a little bit how to scale that type of thing myself. So that's really good, really good piece of information to know.
Yeah. So now what I'm doing now is planning the whole process. And again, what you're seeing in this example, this is literally how I would create, an e-health system. This is how I would create a legal system. So now I've got came up with a Supreme Court framework, the Alice Mayo eligibility test. Like, okay, first of all, never heard of Alice Mayo eligibility test, so I'm going to have to do a little bit of background here, reading to make sure that it's not bullshitting me into something that's not a thing. But you can see here that it's giving me some foundation for what that means and why it's saying it's important. Here's some court cases, recent federal court decisions on AL. So this is some grounding information that it's giving me, some guidance on evolution between 2024 and 2026. So this is recent court-related information that it's gotten me. Now, the key to any of this stuff isn't to just blindly accept it. Like, if I don't understand what it is, then I'm going to have to take some time and go through the process of understanding why it suggested vector similarity search patents and so on. I kind of get an idea why it's giving me this. I'm using a lot of HNSW. But this is giving me some grounding. And here's some appeals related information, patent appeals, processes. So this is giving me some more, this is probably more up John's alley, but this is showing the workflow for how this appeal process generally works. So this is going to be fed into the GNN. So once you've got a GNN, then the GNN is going to learn sort of what and how to instinctively know that this is the process for how the appeals process works. Now, inversely, I want to avoid this, right? I want this to not have to be a thing, but this is, and it's expensive to do appeals, $8 to $20,000 according to this. So again, it's discovered that based on all the things, and this is goes and goes and goes. This is a lot of detail. Do I have any data yet? Yeah, here we go. So now we have data. It's probably still working through its. Here we go. Here's some freedom to operate JSON. So this is the analysis of the RubeNet portfolio. So it's looking at related cases and liabilities. So again, keep in mind I haven't built this yet. This is the underlying. Oh, look, it says the Agentic AI Foundation Linux owns the MCP protocol. So it's saying that that could be a potential liability for me, which we know 100% it is. Which we need to get that letter out too, right, John? But this is the way you architect a legal agentic system. We could probably use this for the stuff we're doing. Maybe when I get back from Portland, we can I'll give you guys a little sneak peek of it. Yeah. So, it's I don't know. Maybe I'm crazy, but that's how I build the stuff.
Ruth, I
And
wanted to
get ready.
ask. Oh,
Yeah.
sorry, we're running out of time. So I was like trying to build something like along similar lines, but not like at the critical level of like legal stuff. But I want to like do like a writer's room to try to do like SNL skits or something like that. And I'm wondering if I can approach it similarly with like kind of defining the space and having it learn that min cut of what a sketch really isn't to approach it.
Yes.
Yeah. Because it's
Well,
hard to get these things to be funny because they'll kind of track in one specific way and kind of go off on that. And
comedy
we're not that
is often a
big.
min cut. It's
Yeah.
you're it's funny because it's the thing it isn't.
Yeah. And I think that's a really interesting thing that you found with the min cut that like unlocks a lot because it's hard to define what it is because it's infinite. So you can't really program that. The min cut allows you to kind of define what's not. It's a small, efficient way of defining the space. And then you can kind of let the LLMs kind of play around in the space it's allowed to play in. And I think that's a decent approach. And it seems like that's what you're doing.
That's what I'm doing. That's exactly.
Yeah.
So, and then it's allowing for self-discovery based on
Yeah.
integrity and simulation
Yeah.
and real-time simulation. There's been min cut around for a while, but before December it required recalculation. So if you did a simulation and one vector, one element, one parameter in that simulation changed, you'd have to recalculate the entire simulation. And what happened in December with the dynamic min cut algorithm that was theoretical and I took and made actually real is suddenly I could do really complex simulations, millions or billions of different variables, parameters, and elements in a graph structure. And if one of those billion parameters changed, I didn't have to recalculate the entire simulation to get the new answer. And what that meant was suddenly I could, in the terms of a DNA analysis, what would take hours now could take milliseconds because I could do that both in parallel, many different versions of the same thing with slight variances of each of those different things without recalculating the entire thing. And a lot of things like DNA, you don't have to do everything all at once. You just want to do the one thing.
Of improving the DNA.
Proving or finding the problems and correlating or finding the unknown interaction points within the DNA or whatever it happens to be, or more interesting, seeing that suddenly the DNA is actually not even a data storage, it's actually a series of coordinates that maps to a secondary space. That the variability to do that across 6 billion pairs would have been astronomical amount of computing power because I'm doing that 6 billion things many times. Now, the traditional approach to doing 6 billion things many times is to use some sort of matrix math, which is a GPU. But the problem with the GPU is you're kind of blasting it and saying, tell me everything, and it's not really finding the thing. It might, obviously, there's different ways to do it, but it's not running that sort of multi-part, multi-step simulation, which tells you the sort of intersection and coherence of the thing you're looking for. Where does it intersect? Out of the trillion different possibilities, what's the most likely path of intersection for the thing that I actually want? So what I'm looking at is only the one thing that I want and sort of pushing everything aside. So when you think about quantum computing, the problem with quantum computing is noise. It's like, how do I discern the good from the bad when 99.9% of it is just noise that's not necessarily and doesn't work? This filters that almost instantaneously and gives me that particular signal. And then once I've discovered that signal, I can then take that, create a trajectory, GNN, and a bunch of other things and say, next time I need to find that signal, I can find it in microsecond because I've already learned how to navigate the system to find that.
Interesting. What library can I leverage for MinCut that's like from yours?
Specifically, it's called MinCut, but I've got several at this point. But the most interesting ones, I've actually got a MinCut transformer. I've got all kinds. I've been like, I know most people think I'm nuts, but the MinCut stuff is my secret. Not really a secret, you guys know it. But if you go into crates and you'll see, oops, my MinCut. Where did I put it here? I've got a bunch.
Do you have it like integrated in like what do you think I should try to like use as a library if I'm doing this like SNL?
The whole well, MinCut is in all my stuff at this point. You could just literally just ask it about it, MinCut, and you'll get it. I've got a decent amount. So I got dynamic MinCut. Where's as attention? I've got a MinCut transformer. This is an interesting one because this acts as a kind of dynamic attention. So what I'm doing is I'm applying an actual attention model directly in the spine of the data itself, which is kind of cool. And it's great for sort of exploration. I've got
cool
examples. MinCut. This is probably the one you want. So this is the network that thinks for itself.
Okay, and this
is the key insight. This is what started it all. What if your infrastructure could heal itself before you noticed it was broken? What if a drone could reorganize mid-flight without any central command? What if AI knew exactly where its own blind spots were? Right? And that's the key. It's the anti-pattern.
Cool. Thanks, Ruth.
So yeah, it all starts from here. And this is a crate. I think I've also got a NPM library, and there's a bunch of other it's at this point it's pretty well infused into everything. Like even the DNA one uses, I think, MinCut in here. Where did I put that?
Roof.
Yeah.
Roof,
Yeah.
are you planning to now that you have the quantum implementation, are you planning to go back and improve stuff that you already built? And definitely this will improve performance on everything. This is
I got, you mean my old quantum system? I think I built that in Python. Maybe.
Or maybe already the package that we're using for all the other implementations. Is quantum able to the way they improve the performance of the DNA implementation?
It just
why
DNA
not
just
to
maps.
use it? Why not to use it in the other packages?
There's only so much time in a week. I don't know.
Okay.
Yeah.
Yeah, understandable.
All right. Hopefully that was helpful for you guys. I gotta jump.
Yeah, of course.
All right. Till next time. Thanks, everyone.
Thank you.
Thanks.
Thank you.